Hi, welcome to our channel of IGNOU audiobooks. Indira Gandhi National Open University, School of Engineering and Technology, SOET, Diploma, Postgraduate Diploma Programs. Diploma in Smart City Development and Management, DSCDM MIO 003 Smart Urban Energy and Smart Transportation Systems. Block-1 Smart Energy. Unit-1 Introduction to Smart Energy. 1.1 Introduction. Smart energy is the method of using devices for energy efficiency. It focuses on powerful and sustainable renewable energy sources that promote greater respect for the environment while reducing costs. The word smart energy and smart energy systems have recently been introduced to broaden the notion of smart grid. While smart grids primarily focus on the electrical sector, smart energy systems, or smart energy grids, also cover heating, cooling, industry, buildings, and transportation. Smart energy regions are defined as areas that provide maximum quality of life to their residents while consuming the least amount of energy possible by integrating infrastructures, energy, mobility, transport, communication, etc. Realizing this may need a powerful communications infrastructure that allows for pervasive and dependable information transmission among sensors and actuators. Matthew Nosadiku, 2021 Objectives. After studying this unit, you should be able to define solar energy, explain smart energy, describe solar energy application in smart cities, explain solar street lights, solar panels and solar floating PV panels. Smart energy is defined as the effective use of energy through enhanced design, high-efficiency technology, and conservation, as well as the use of clean, renewable resources to generate power, heat, and transportation fuels. The smart energy network is a component of the electrical energy system, which is a key infrastructure that supports a wide range of critical and non-critical infrastructure. It would be a system that is robust in the face of adversity and capable of recovering quickly from calamities. The smart energy system and smart meters are the two main components of smart energy management. Smart energy has the potential to cut family and corporate energy expenses. It also cuts demand for oil and gas while also creating new green employment. It will create new markets for distributed zero-emissions energy sources like solar and wind. Efficient energy usage is critical to achieving smart energy goals, as well as land protection, water quality, and other environmental goals, since it results in long-term cost savings and increases the likelihood of fulfilling our future energy demands through renewable sources. Through the use of smart energy technology, traditional buildings may be transformed into smart buildings, resulting in sustainable energy. A smart energy system would include new types of flexibility such as energy storage, demand-side response, smart networks, and connectivity. At present, the importance of smart energy is increasing, with companies making smart energy systems a top priority. This increased investment in smart energy systems has many benefits for consumers, the environment and energy providers in general. 1.2 Solar energy. Solar energy is used around the world and is increasingly popular to generate electricity or to heat and desalinate water. Solar energy is produced in two main ways. Photovoltaics, PV, also called solar cells, is an electronic device that directly converts sunlight into electricity. The modern solar cell photovoltaics is as shown in Figure 1.1 is probably an image most people would recognize. They are founding panels installed on homes and in calculators. These were invented in the year 1954 at Bell Telephone Laboratories in the United States. Figure 1.1 Photovoltaic. Look at the screen. Solar PV installations can be joined together to provide electricity at a commercial scale, or arranged in smaller configurations for mini-grids or personal use. Solar photovoltaic energy may be used to power mini-grids, which is a fantastic method to supply electricity to those who do not live near power lines, especially in developing nations with abundant solar energy resources. Solar panels are becoming more economical and the cheapest type of energy due to lower production costs. Solar panels have a life expectancy of around 30 years. Concentrated solar energy, CSP.
It uses mirrors to concentrate the sun rays. The rays then heat the fluid, creating steam to run a turbine and generate electricity. Figure 1.2, CSP plant diagram. Look at the screen. The CSP plant is as shown in figure 1.2, has mirrors that redirect the rays to a tower. One of the main advantages of a CSP plant is that it can be fitted with molten salts in which heat can be stored to generate electricity after the sunset. 1.3 Solar energy applications in smart cities. Master plans for smart cities include both in-city and off-site power generation systems. When it comes to off-site infrastructure, the 100 GW solar roadmap by 2022 envisions 20 GW of power generation through solar farms. An additional 10 GW will be implemented with the help of farmers. However, the mission in town received massive priority with over 40 GW coming from rooftop solar power plants. The proliferation of solar PV systems across the world has also dramatically reduced the prices of solar panels. Now, the use of a solar panel on the roof for the home is not limited to water heaters. Several countries have shown a massive boost in powering entire homes and shops with photovoltaic panels. More than 16 states in the country have already put in place policies to encourage the use of solar energy. Off-grid solar systems are also on the rise. Small commercial establishments and large homes can be fully powered by 1 kilowatt solar panels available in the market. The design of the off-grid solar system consists of only three main components: an inverter, a battery and solar panels. The installation is quite simple and significantly reduces the dependence on power from the network. The difference between off-grid versus on-grid solar system is shown in figure 1.3. Figure 1.3, Off-grid versus on-grid. This initiative is highly recommended to achieve an energy efficiency of 80% in buildings such as offices, schools, residential centers, etc. Installing solar panels can also power street lights, water pumps, traffic lights, poles, flashing resources needed to ensure a successful implementation. Per city, the Ministry of New and Renewable Energies provides us 50 lakh to implement solar energy. To develop solar cities, urban local communities called solar city cells are being set up. Citizens are encouraged to approach local organizations to exploit this resource and bring greener energy into daily life. In 2019, India's solar installation stood at 26,984 megawatt on the ground, while the rooftop solar power plants have a capacity of 1,796 megawatt. There is huge potential for a rapid increase in the use of rooftop solar installation, as it is easy to implement and offers many economic benefits to users. A one-time investment, SPV roof panels are both economically and environmentally beneficial for users. Initially, 8 major cities were selected to make smart cities, which are Amritsar, Delhi, Mumbai, Bangalore, Chennai, Vizag, Kolkata and Myanmar. 34 solar cities included in the list of smart cities in stage 2 are Guwahati, Raipur, Bilaspur, Panaji, Gandhinagar, Surat, Rajkot, Faridabad, Hubballi Dhardwad, Kochi, Bhopal, Indore, Gwalior, Thane, Nagpur, Kalyan Dombivli, Aurangabad, Imphal, Aswal, Kohima, Bhubaneswar, Newtown, Kolkata, Chandigarh. Gift, Gujarat International Finance Tech City. Gujarat International Finance Tech City, GIFT, is a Gujarat government-sponsored joint venture commercial area. It is India's first smart city. The city has a district cooling system, an underground utility tunnel, and automated vacuum trash collection, among other things. The city is designed for walking and includes commercial and residential complexes. The project is located on the bank of the Sabarmati River and approximately 12 kilometers, 7.5 mi, from Gandhinagar International Airport. A dual-corridor metro system is planned to connect Gift City with the airport and various parts of Ahmedabad and Gandhinagar. DU. In 2018, DU became the first union territory to run 100% on solar energy as part of the Smart Cities mission. Through the use of solar power plants, 13 megawatt of solar capacity was installed in just 3 years. A 9 megawatt solar park spread over 50 hectares is now the city's lifeline. The 22,000 inhabitants of DU benefit from the economic advantages of solar energy, with a 15% reduction in electricity prices. Ecologically, the success is even more worthy of celebration, as the city now saves 13,000 tons of carbon emissions each year. 1.4 Solar panels. A solar panel, or solar module, is a component of a photovoltaic system. They are made up of a series of photovoltaic cells arranged in a panel. They come in various rectangular shapes and are installed in combination to generate electricity. Solar panels, which are also called photovoltaic, collect energy from the sun in the form of sunlight and convert this energy into electricity, which can be used to power residences or businesses. Figure 1.4, Solar Panel System Connection Diagram. Look at the screen. In addition to residential and commercial use, there is large-scale industrial or utility use of solar power. In this case, thousands, if not millions, of solar panels are arranged in a large solar array, or solar farm, as shown in figure 1.4, which provides electricity to large urban populations. Solar panels are used to assemble a series of solar cells so that their unique properties can be used to generate electricity. Individual cells absorb photons from the sun, which causes an electrical current to be produced in the cell through a phenomenon known as the photovoltaic effect. An inverter is used to convert the direct current produced by the solar panel into alternating current. Combined of these two technologies create a photovoltaic system. When installing a solar panel, the proper orientation is chosen so that the solar panel is oriented in the most suitable direction for the specific application. Most of the time, this involves producing the maximum amount of energy per year, but this is not always the case. No less than 26 public buildings in the city have been fitted with solar panels as part of the Smart Cities mission. Once commissioned, the project could reduce public expenditure on electricity and reduce carbon emissions from power generation by about 3 tons per day, compared to emissions from thermal power generation. The signs were installed on 21 Kochi company buildings and 5 government buildings. They include the company office, town hall, Gandhinagar fire station, Ernakulam General Hospital, Thevara Nursing Home, Government Girls High School, Kochi, Government Upper Secondary School and the Maharajas College. The panels above the town hall have the highest generation capacity of 80 kilowatts, kW, followed by the General Hospital, which can now generate up to 70 kilowatts. In total, the panels can generate around 3,000 units or 1,000 kilowatts per day, provided the sky is clear. Producing a unit of thermal energy can release around 1 kilogram of carbon dioxide, according to officials at Cochin Smart Mission Limited, CSML. 1.5 Solar street lights. Solar street lights are gradually replacing the widely used traditional public street lights. They have a crystalline silicon solar battery to provide power, a controlled maintenance-free battery to store electricity, an ultra-bright LED lamp as the light source. And they are controlled by an intelligent charge and discharge controller. Composition of solar street lights. Solar lighting solutions are composed of an LED lamp is shown in figure 1.5, for optimal lighting, a solar panel, to capture the sun's rays, a storage battery, a solar street light controller, a floor lamp, etc. The main products are monocrystalline silicon solar panel and polycrystalline silicon solar panel, powerful LED source, controllers located in the lamp pole, storage battery, valve-regulated lead-acid battery, VRLA, and gel battery, underground or some incubator. Figure 1.5, Solar Street Light Diagram. Look at the screen. How these solar streets do lights work. The solar panel, under the control of the intelligent controller, captures solar energy and converts it into electricity when the sun's rays hit the solar cells. The storage battery is charged by the solar battery during the day, and then it powers the LED lamp at night. The controller plays a very important role in protecting the storage battery from overcharging or over-discharging. Energy XPRT, 2021. Pros times the solar street lights are independent of the electrical network. Hence, the operating costs are reduced to minimum. Times solar street lights have a very less maintenance cost as compared to conventional street lights. Times as the outer wires are eliminated, the risk of accident is minimized. Times it is a non-polluting source of electricity. Times separate parts of the solar system can be easily transported to remote areas. Cons times the initial investment is higher compared to conventional street lights. Times snow or dust, combined with humidity, can accumulate on horizontal photovoltaic panels and reduce or even stop energy production. Times rechargeable batteries will need to be replaced several times during the life of the fixtures, increasing the total cost of the life of the light. 1.6 Solar floating PV panels. Solar panels that float above water are known as floating solar, floating photovoltaic, FPV, or photovoltaics. Solar panels should be linked to a floating framework that allows them to remain above the water's surface. Floating solar systems are also prevalent on big man-made bodies of water, like as reservoirs. The first patents for this type of technology were filed in 2008. Since then, floating solar has mainly been installed in countries like China, Japan and the UK. A solar floating PV panels is as shown in figure 1.6. Figure 1.6, Solar floating PV panels. Look at the screen. 1st June 2001 Advantages of photovoltaics. No loss of precious land space. The biggest advantage of photovoltaics or solar floating PV panels is that we don't require floor area for the installation. Many of these facilities, such as hydroelectric dam reservoirs, sewage treatment ponds, and potable water reservoirs, can take up underutilized space on water bodies. Additionally, installing solar panels on open water reduces the need for tree felling and deforestation, a practice used with some larger solar panel installations. Higher solar panel performance. Solar panels are made durable to operate at high temperatures. But as with other electronic devices, higher temperatures result in decreased power output. Solar panels' efficiency decreases as temperatures rise, which might be worry for homeowners considering solar panels in a hot, sunny environment. Bodies of water that house floating solar panels help cool solar equipment, meaning the panels produce electricity with higher efficiency in hot climates than they might otherwise. Environmental benefits. With floating solar installations, water not only has a cooling effect on solar equipment, it also works in the other direction. This is a particularly useful benefit in drought-prone areas, as water lost through evaporation can build up over time and contribute to scarcity. It also helps in reducing the formation of algae in freshwater, which is dangerous to human health and is also responsible for the death of aquatic life. Finally, floating solar panels are a source of clean, renewable electricity. The use of renewable energy technologies helps reduce emissions of greenhouse gases and other pollutants into the atmosphere, leaving a positive impact on the natural environment as well as on human health. 1.6 2 disadvantages of floating solar. Costs. When compared to more typical forms of solar panel installations, floating solar systems may incur higher expenditures. As it is a new technology, it requires skilled knowledge for installation than installing similar-sized solar farms on rooftops or ground. Applications. Floating solar systems don't work for everyone. The vast majority of floating solar systems are large-scale, providing power to utility companies, big towns, enterprises, and municipalities. If you are looking for solar power for your home, then it makes a lot more sense to install a system on the roof or on the ground. Those who invest in floating solar often have access to a large body of water to install hundreds or thousands of solar panels. Unlike these types of installations, the average residential solar panel system has around 20 panels. Installation companies and developers who install floating solar projects today are not doing so on small-scale installations. Thank you. Subscribe to our channel for more updates, and we will see you with the next chapter.